And let's see, I can ask Jameson these questions, but where does he go to school? Huh. Oh, really? Well, yeah, you don't need the dashes. Just, yeah, put the 9 digits in, just straight 9 digits. I think. Like I said, I'm never on your end, so. And let me look at it again. 376-604-493, yes. Mm-hmm. Now, there's actually 2 programs. There's Gotomeeting and there's Join Gotomeeting. What I usually send people to is the Join Gotomeeting. I'm not sure that they're exactly the same software. They come from the same producer, but one is for people who are hosting the meeting and the other is for people who are joining the meeting. So you might want to just, let's start from scratch and point your browser to joingotomeeting.com and then put in that 9 digit. Oh, no, you're on there. Yeah, you're okay. Yeah. Yeah. Okay. Now, there's one last thing you have to do. You have to go up to audio, and you want to use the computer audio, and you also want to unmute your microphone. The microphones always come muted when you log into a Gotomeeting, which is just a line that goes through the icon on your microphone there on the Gotomeeting panel. I don't hear anything coming out of my speakers, is why I don't think you have your microphone turned on.
Sorry.
Now we can hang the phone.
All right.
Okay.
There we go. Okay.
Yeah, and you kind of need to hang the phone up because there's feedback that comes in if you don't. So can you hear me okay, Jameson?
Yeah. Yeah, I got you.
I can hear you good too. The audio generally is awfully good on Gotomeeting. It's better than what we would have on the phone. So
yeah.
So you are a geometry student at Dakota Ridge. I live in King Carl. So I live really close.
Mm-hmm.
What year are you, Jameson?
10th grade, sophomore.
Okay. And what are you getting in geometry right now?
I think it's a C right now.
Okay. How'd you guys find out about me?
Through the teacher that's there.
Oh, okay. Yeah,
I believe.
I've lived in the area for 10 years, so I have a lot of teachers in both Chatfield and Dakota Ridge that are familiar with me. So, okay. With every subject other than geometry, a student can usually verbalize stuff, verbalize problems like algebra. If you had an equation, you could tell it to me. I would write it on my screen, and then we would proceed to solve it. With geometry, it's a little different because you're generally dealing with stuff that you can't verbalize. In other words, it's difficult to verbalize, a drawing of a parallelogram that they've given you or something.
Right.
So the best way to do geometry is for you to take a picture of the material. Unless we happen to have the same book. Do you have a geometry book?
No, I don't.
Okay. Yeah, I was going to say half the students anymore don't get books. So, so whatever material you want to cover, the best way is to take a picture and send it to me, and let me write the best email address. And you don't want to send it to my phone, you want to send it to my email address, because then I'll be able to bring it up on our screen and we'll both be looking at it.
Right.
And there's not too many geometry problems I can even think of where you could verbalize it. So you almost have to send a picture in order to be able to do geometry online. But if you can read that, and what kind of phone do you have? Do you have an Apple?
No, I have a Samsung.
Okay. Go ahead and take the picture of whatever material you want to cover today and send it to that email address. And as soon as it says sent, let me know and I'll look and see if I can bring it up.
Okay. I'm going to get out my math notebook real quick.
Okay. Still there? Feel like we might have lost.
Okay.
Oh, okay. We still have audio. Good.
Yeah, we're good.
Okay. What kind of stuff are you working on right now?
Circles is the unit we're in right now.
Okay.
Okay, I just sent an email over
Okay.
of some pictures from the book.
All right. Let's have a look.
I hope that they came through well.
It needs to say sent on your end. File sent. And you need to attach the email as an or the picture as an attachment.
Yeah.
I haven't gotten it yet, so I suspect that it hasn't sent yet. You send it to David Cowan 1949 at gmail.com.
I'll look it over again.
It's got to be spelled C-O-W-A-N. A lot of people misspell it C-O-W-E-N. Huh? Something just came in. That was my phone telling me I had an email. I bet that's it. Yep.
There we go.
All right. Which one of these do you want to look at first? The one on the right?
Sure.
I don't know if you can see them or not.
Yeah.
It looks like the one on the right is going to start from 1. It's a good picture. Good resolution. Where do you want to start?
Wait, what page is this all in right now? Like in the book?
No, it's here, let me scroll to the bottom. 683.
Perfect. Okay.
This looks a lot like my book. Hold on a second. You may not have to send stuff to me if we happen to have the same book. No, not exactly the same. Okay. So is this the page you want to look at?
Yeah, this is good.
Which problems? The way my tutoring works is I pretty much just do problems. When I see a problem that you don't know how to do, then we can cover, math theory that's necessary to teach you how to do that problem. But it's pretty much all problem based. In other words, I'm not going to sit and lecture you about circles for 15 minutes. I'm going to go through problems about circles and see what it is you know and what it is you don't know.
Right. So why don't we start off with 4?
Okay. So they want DEF.
Mm-hmm.
And what we know is FDT is the 117.
Yeah.
Let me think about this for a second. So what do you know about this picture?
That's an inscribed angle, right?
Okay. So what does that tell you?
That we have to double the 117, right? To get EF at least.
Well, they want the measurement of this. Okay.
Ah.
Now, if they wanted the measurement, here, excuse me, I wanted to erase that. If they wanted the measurement of just this, then it would be double
Mm-hmm.
Hold on a second. First of all, tell me yeah, no, this is very straightforward actually. I don't know why they want the measurement of that. Correct?
Yeah.
And you're
Yeah.
right, it's double. So what's the answer?
Um, 234.
Yeah. I'm trying to figure out why. Yeah, there's nothing special about that problem. Okay, how about number 5? What's the measurement of angle 1?
130, right?
Uh-huh. It's half. And let me scroll down. Do you have to do all of these or just certain ones?
Certain ones.
Okay, what's the next one? You direct. That's the other thing is
Okay.
that I always have the student direct because
Okay.
you're the one that knows what you need to work on.
Okay. The next one is 6. We're doing all the even numbered ones.
Okay.
Up to 12.
Okay. So AB is a chord that is not the diameter. If it was the diameter, what would angle X be? What does it look like it would be?
I know that half a circle or a diameter is 180 degrees.
Exactly. And you
Okay.
also know that the tangent line makes a 90-degree angle with the diameter. In other words, if this was a diameter, oops, hold on a second. Let me get so I can write on this thing. Computer's acting up. Ah, there it is. It was just late. Hold on. Still having a hard time getting my Windows Ink workspace to come up so that I can write on this document. Well, I don't actually need to here. X would be 90 degrees if AB was a diameter, just because
Yeah.
tangent lines make 90-degree angles with the radius or the diameter line. So we know that X would be 90 degrees if it was a diameter. So
Yeah.
the fact that they're saying it's not a diameter line, you can certainly cross out C. Can't be C. D, on the other hand, has to be correct. And if you assume that only one statement is correct, then it has to be D. You might think that A might be the answer because it says X is less than 90 degrees, and if we look at it, it's clearly less than 90 degrees. But remember, it says not drawn to scale. So we don't know which side of the center of that circle that line is on. It could be on the other side. So it could be less than 90 or greater than 90. The only thing we know for sure is that it's not 90. It would have to be 90 if it was a diameter. And if it's not a diameter, then it's not 90.
Yeah.
All right.
Okay.
Number 8. Find the value of X. So what is the general equation that applies here?
Let me see if there's anything in my notes. Okay, I think I might have an idea.
Well, there's, hold on one second. Let me make sure that I'm in the right section of the book. I wasn't. Make sure I don't give you any bad equations. So what do you feel the relationship is between this angle here? Let me write it, just a second. It's the relationship between that and that.
They're opposite angles.
Well, they're the two arcs that are cut out by two chords that don't necessarily cross in the middle. Okay. This angle right here, which is the same as that angle right there, is going to be, I believe, half of the sum of x plus 45, the arc measurements. That's the way I remember the formula. Now, let's see if that makes sense. First of all, what is that angle? In other words, you can figure out what these angles are. What is this angle right here? What's true between this angle and 122.5 degrees? What do they have to be? They're a linear pair. In other words, whenever you have two angles like this, 1 and 2, always at 180 degrees. Okay? That's what we're looking at there.
That's right.
Straight line.
Okay.
There's that. So this has to be 57.5. Okay? And now you can say that if I know that angle, then I can figure out the measurements of these arc lengths, because I know that 1/2 of x plus 45 has to equal 57.5. So x plus 45 would equal 115. X would equal 70 degrees of arc measurement.
Okay, yeah, that makes sense.
Now, let's just talk for a moment about how to memorize some of this stuff.
Okay.
There's a lot of things to memorize when you get to circles. Okay? There really are. And one way that might be helpful, there's certain techniques you can use. If I have a circle and that thing was right in the middle, their intersection point, well, then I know that whatever this angle here is, this has to be that same thing, and that angle has to be that same thing, because they are starting from the middle of the circle, and these angles are equal to the arc measurement if it's coming from the center. So if my formula was correct, then 1/2 of this A plus that A, or 2A, has to be equal to A. And that's true. So that kind of reassures me that the formula I used is the right one. In other words, even though we're not crossing in the middle of the circle, the center, that still is going to be true. And in fact, if I drew my circle like this, where I had the intersection point here, well, I already know that this angle 1 is half of this measurement right there. So by using a combination of some of these things, you can verify that your memory of the formula is true. Okay, let's look at number 10. There's a formula that involves two tangent lines. That's what this is. That's one tangent line. That's another tangent line. This angle right here is equal to half of that arc measurement minus that arc measurement. So what is the smaller one? In other words, what is this measurement from here to here, going in that direction?
Oh, 113.
Okay, so now you take 247 I know I'm not going to add, because if I added it, I would get 360, and then that would always have to be 180, and I can tell that's not 180. So I got to subtract it, and then I got to take half of that. Now, does that look like a 67-degree angle?
Yeah.
Yeah,
I'd say so.
It does, yes. And that is the right formula, is half of it. And as long as we're talking about that, let's talk about very similar situations, which would be where I have a circle and I have one tangent line and not a tangent, but a secant line, like that. Well, it's the same formula. Angle 1 equals 1/2 of the measurement of that arc minus the measurement of this arc. So it's basically the same whether you're dealing with tangent lines or two secant lines or one tangent line and one secant line. It's always 1/2 of the larger arc minus the smaller arc. In other words, you're intercepting two different arcs there. All right, you said evens, so 12 would be next?
Yeah.
Notice these are all three the same formula. That one, and this one. You either have two tangent lines, or you have a tangent and a secant, or you have two secants. But they're all the same formula. So tell me what equation I can write from number 12. Because that's usually in geometry problems like this, your first goal is to come up with an equation and then solve the equation. And let me scroll down a little bit here so we have a little more room. Pretty much always what you're looking to do. So I know that this angle is equal to what?
34 degrees.
Okay, but what's it equal to in terms of that arc and that arc? Half of the difference. This one is half of the difference. That one is half of the difference. In other words, all three of these use the same formula. They're all, that angle is 1/2 the difference between what and what?
X plus 6 and 3x minus 2.
Well, you want the bigger one first, which is always the outside one. That's always going to be the bigger one.
Right.
Minus, and now you make sure you put that in parentheses, x plus 6, because the angle is x plus 6. Okay? And that's going to allow us to solve for x. In other words, now we have one equation, one variable. So let's solve for x. I get 1/2 times 3x minus 2, and I'm going to remove those parentheses. And now I'm going to simplify. 1/2, I got 3x minus x, that's 2x. Minus 2 minus 6, that's minus 8. That's all equal to 34 degrees. I'm going to multiply both sides by 2. I get 68 equals 2x minus 8. 76 equals 2x. X equals 38 degrees. That look right? Hard to actually tell. We're not looking at this angle. That angle's 34 degrees. But if x is 38, then this little measurement right there would be 44. Yeah, that looks about right. And if x is 38, then this one is going to be 114 minus 2, 112. And that looks about right. So in other words, we always want to do what I call a ballpark check, which is where you eyeball it and you make sure that, if it looks like an acute angle, it is. If it looks like an obtuse angle, then make sure that it is, and so forth and so on.
Right.
Jameson, it's 4:30. So this first session is only a half hour long. It's free of charge. Do you know my website?
Yes, I do. I have it bookmarked on my computer now.
Okay. And you know how to sign up for sessions. So
yeah.
You're on your own now, particularly if you're interested in online sessions. Then you can go in anytime you want. You can see my availability. You can sign up. We'll have a session. If you want an in-person session, it's a little bit more complicated. The timing is you have to allow for some travel time for me. But sounds like you're probably okay with online.
Yeah.
If you do want an in-person session, I live close enough to you that I'd be happy to come to your house, or we could meet at a Starbucks or something like that. Call me and we'll schedule it rather than doing it online, because you have to schedule it a half hour in advance of when you actually want it. It's a little bit more complicated. But if you're just looking for online, then you should be good to go at this point.
All right.
Okay. Well, Jameson, nice to talk to you, and look forward to working further with you.
Yeah, me too. Thank you for your time.
Bye-bye. You can close out of the Gotomeeting by just clicking on the X in the upper right of the Gotomeeting panel. All right. Bye-bye.
All right. Bye.